Okay, so this is the course website. So if you click on expand, you will see this is today's lesson. So we're going to teach you something about functions. Um, and there's a summary, like in PowerPoint format. So if you can open summary, you will see the slides here as well. So this is basically a summary of what we're going to talk about today. And as for the programming part, all the code are here. So if you click on the code, you will see all the source code here as well. They're on GitHub. So I will teach you how to access GitHub later. But for now, you can just know that, like, so for every lecture, for every lessons, we have like this book format that has detailed explanation of the math concepts. And then we also have slides that are summary of the lessons. And then we also have the source code that goes with it. Okay. So today's lesson is on functions. I think like most of you probably do not know about functions yet, or maybe except lesson, because you're older. So basically, a function is probably the most important concept in mathematics, because lots of mathematical objects can be actually defined in terms of functions, such as like numbers, variables, groups, stats. They can all be defined in terms of functions. So function is actually one of the most important concepts in mathematics. So let's start with function, because function is also the most important concept in programming as well, because in programming we define lots of functions. So what is function? So we need to give it a definition. So in mathematics, a definition just means meaning. Whenever we want to define a new concept, we want to give a meaning to that concept. Okay, so let's say we define an object, so we need to tell people what that means, and that meaning we call it a definition. So in mathematics, it's just all about definitions. So we define numerous numerical concepts, and then we play with this numerical concept, and then it usually gives you interesting things. So what is a function? A function is like a factory. It takes some input, and then it will also give you some output. So you can think of like a function is a machine. You put something into it, and then it will crank out some other stuff. Okay, so it's very easy to understand. You give it something, you give it something back. So this is what a function is. Okay. Although this concept is very simple, but actually it's the foundation of mathematics, and we are going to learn about it. But I said this is a math programming class, so we are going to do some programming. So before we can do that, we need to go to this website. If you type s21.nm.path, it will give you a programming environment that you can start doing some programming. Okay. You have to open a browser and go to this this website. So this is now a very advanced calculator. So the first thing that you need to do is to open a blank slate. Okay. So we want a blank page, so we can start doing some programming. You see this little plus sign here. So if you click on this plus sign, and then click on notebook, so you're basically creating a notebook. Okay. Everybody see that? So we're going to do some experiment just to get Gary up to speed with some simple math programming stuff. So the very first simple thing that you can do is like 1 + 1. Everybody try that. 1 + 1 should give you 2, right? So this is like a calculator, so you can do a lot of cool mathematics with it. But let's start with just arithmetics first. So Sebastian, are you okay? Can you type 1 + 1? Does it give you 2?
I don't know what slide are we. I mean, I don't know like what.
Okay, can you share me? Can you share me with your screen so I can see what you're doing? So make sure that you're on the same page. You know how to share your screen? Okay, so you click on that plus sign, that little plus sign. Or you can click on, yeah, you can click on that one too. Yeah. And then open a new notebook. Yep. Yep, just click on that. Yep, there you go. So this is the new notebook that you can use to do any computation. And then, oh, you need to press Shift Enter. So after you type something in the cell, you type Shift Enter. So you need to press the key Shift and Enter at the same time. Yep. And then give it true. Yeah, there you go. That's very good. So this is your first line of coding. When I type value, a equal to 1.0. So this is how you define a constant in computer. Okay. So you type this and Shift Enter, and then you type a and then Shift Enter. It will give you the value of this symbol that you just defined. Okay. So we can define another symbol called EE, E the little boy, equals 2.0. Okay, we can do that. And then when you type this name, so this is the name of the symbol, it will give you the value of this symbol. Okay, you got that? And this symbol, you can actually use it to do mathematics. So we can say A plus E the little boy. It will give you what? It's just the same as 1.0 plus 2.0. Okay. So try to define some values and let me show me your screen so I can see it. Okay. I want to see that you can actually define the value and do some manipulation with it. So I can do A. Oh, you can do B equal to 2.0. Okay. And value C equal to minus 1.0. So always add 0.0 at the end because this is how we define a floating point number or decimal number on computer. And then we can type them out. So you say A, B, and C. Okay. So we can do B times C. It's the same as minus 1 times 2. We'll get like minus 2. Okay. So this is how we define a value, a constant. But you cannot change it. So this is a constant, so you cannot change it. So if I say A equals to 2.0, it's not going to work. It give you an error. So all these messages are errors. Okay. So it means it's not going to work. This doesn't work. It says value cannot be reassigned. It means that A, once you assign a value to it, you cannot change it. So it stays as 1.0 forever. Okay. Abby, can you tell us the difference between VAL and VAR?
VAR can change and VAL can't change.
Okay, that's right. Okay, so so if you let me go back to my presentation. Am I presenting, by the way?
Is that you?
Yeah, can everybody see me timing DDDD?
Wait, are you the DDDD one where?
Yeah, I'm the DDDD one. Yeah.
Okay, yeah, then you're presenting. Check chat. Check chat.
Okay. So finally, we are ready to define a function. Okay. So what is the function again? Can someone tell me what the function is? Sebastian, can you tell me what a function is? You may have forgotten, but what's the function?
Wait, is this a function right here? One simple function to identify function and always produce an output exactly the same as the input?
That is the simplest function that we can define. Okay, but that's an example of a function. But what is the definition of a function? What's the meaning of a function?
It works.
No. Okay, you say what's the function?
You give it input and it give you an output.
Okay, so what's the simplest function that you can think of?
1 plus 1.
Yeah, something even simpler.
I know, 0 plus 0.
No. Abby, can you think of something simple? Some function that is simple.
0 times 0?
No, that's not a function. That's just a number. So remember, a function is something that takes an input and give you an output. Okay, so you need to define what the input is and what the output is. Okay. Okay, Tana, can you say something?
0.
No, 0 is a number. It's not a function. Okay, Sebastian, you want to try? You want to give it another go to define a function?
I don't know.
Okay, good, good. So you know to define a function, you always have to say what the input is and then what output it gives to you. Okay, so for example, the simplest function that I can think of is you give it anything, it always gives you the same thing back. Okay, let's say I give you an apple, you give me an apple. Okay, so the input is an apple and then the output is an apple. Okay, and I give it orange, you give me an orange. So it always gives the same thing as the input. So to make this to make this make more sense, we need to code it up. Okay. So if you type this, okay, I actually if you go to the GitHub page, I have a function here defined already. Okay, we call it the same function. Okay, we call it same function. So if you type this in on your computer, the same. So this is how you define a function. Okay, first you say fun. Fun stands for function. So all functions start with the keyword fun. Okay, because function is fun. And then you give it a name. So the name I give to this function is called the same, S-A-M-E. And then I have the input x. X is the input. Okay, and I say the input is the string. Oh, by the way, in computer science, a string just means a text or a word. Okay, so for example, hello. A string. So we don't call it like a sentence. We don't call it a word. We in computer science we call this a string. So x is a string, and this is the output. The type of the output is also a string, and this is the body of a function. So that basically say, okay, we give it an x, whatever it is, it will give you the same x back. So let's say I type same. So this is how I call a function. To execute this function or to run this function, or to call this function, we type the function name, a bracket, and then the input. So we say the input hello world, and then it will give you hello world back. So whatever you type in here, whatever I type in, I always get the same thing. Okay, so let's try to see if it is the case. Okay, there you go. So this is a function. This is called the same function. This same function is very simple. I think it's the simplest function ever. Is that it takes an input and the output is always the same as the input. So can you try on your computer? In mathematics, we typically don't work with text. We work with numbers. So in order to change this function to work with numbers, we will have to type in something differently. Okay, so we type this. So again, a number in computer is called double. Okay, we don't call it. We use identity, I-D-E-N-T-I-T-Y, because in mathematics there's a name given to this special function. It's called the identity function. Okay, so if you can type this in on your computer, we can try it out. So the identity function does exactly the same thing that it does as the same function. It gives you the same number always. Okay. So if you try this, so if identity 1.0, you give it 1.0. Minus 1.0, give it minus 1.0. And you can type in a very big number as well, 99999. It will always give you the same number. So there's a name to this special function. It's called the identity function because it always gives you the same output as the input. So whatever number that you put in the input, it will always give you the same number as the output. Here's a challenge for you. Okay, here's a challenge before we wrap up for today. Can you define a function on your computer that always returns 0? So regardless of what input I give it, it always returns 0. Can you define a function that does this? Okay, Tana Yi, can you try and show me your answer? And Sebastian, can you try on your computer and then show me your answer? Sebastian, if you share your screen, I can do it together with you.
Okay, I'm gonna share my screen.
Yep. Why don't you give it like 99.0 and see what happens? Yep. Shift Enter. There you go. It gives you 0. And try different numbers.
Okay.
Different numbers to see whether it works. Yeah. Whether it always gives you 0. Why don't you try try a big number. No, this is an integer. Remember?
Okay.
For double, you need the dot zero. You need the 0.0 at the end. No, you can keep this big number, but you need the 0.0 at the end.
Oh, okay.
Yep, 0.0. Yep. There you go. So this is a zero function. So the identity function is one of the most important functions in mathematics. We're going to see it a lot. And also the zero function is also very important as well because it converts everything into zero, which is also another very important function in mathematics.